Welcome to the Stormsurf video surf forecast for the week starting Sunday, February 18th. Looking at significant wave heights for the North Pacific Ocean, we see a gale off of Japan moving to the northeast, producing seas in the 36-foot range, aimed to the east, but likely on its last legs. Also, some fetch producing 26-foot seas aimed south off of the Pacific Northwest, part of a backdoor front, a trough, barely extending off the area here, getting a little traction on the ocean surface. But that, too, is expected to be short-lived. Let's get into the details. As usual, we'll start this week's tour looking at jet stream level winds. These winds, up about 30,000 feet, help support the formation of gales. When those gales do form, it helps direct their track. Right now, we have a good, solid flow pushing off Japan, consolidated flow. That is, the jet is not split. Winds in the, about 150 to 160 knot range in a couple little pockets, but mainly 130 to 140 knots, reaching to the dateline, and then the jet splits, with the northern branch pushing well to the north, due north, up through the Bering Sea, up into Alaska, and then falling south along the Canadian coast, forming a little bit of a trough right here, a dip in the jet stream that's barely exposed off of the coast of Washington and Oregon, maybe supporting low pressure development there. Also, there's a trough off Japan right here. That is a dip in the jet stream that helps form a counterclockwise flow aloft. And down at the surface, of course, that's the hallmark of low pressure, and low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, produces swell. Swell, when it hits your beach, of course, creates surf. Anyway, let's take a look and see what the model suggests is going to happen. And the hint is, or the teaser, or we'll just sort of give it away. Not a whole lot's going to happen for the next 72 hours. Basically, you see the jet continuing, pretty solid, pushing off of Japan. We're out into Wednesday. Let's just take it on out to about Wednesday night or Thursday. Oops, there we go. Wednesday night, let's say. 72 plus hours. The jet continues consolidated, pushing off Japan, reaching to the dateline, splitting, again, pushing well to the north, and then diving down the U.S. West Coast, Canadian, British Columbia West Coast, while the southern branch continues far to the south, pushing over Japan, and the two merging over Baja. So what this pattern sets up is low pressure over, let's say, off the Kuril Islands, in that weak, kind of ill-formed trough there. High pressure between the split jet stream flow, that is, a clockwise circulation. Of course, high pressure suppresses swell development, except when it's right on the edges, and then it can produce some pretty good winds and make some wind swell. That's exactly what's going on. You can see low pressure come Wednesday out in off of the Great Basin here. High pressure over the ocean here. That produces a gradient and tightening of the isobars. That in turn produces wind. And that's the hallmark of what's supposed to go on most this week. North wind along the coast, wind swell, not great conditions. But there is some hope for precipitation working from British Columbia down into California as multiple low-pressure systems drop down this path. In fact, let's go back to tonight. There's the first low-pressure system inland there, but a little bit of precip should come from it. And cold air. This is an Arctic flow. This jet pushing down like this draws cold air from Canada southward, lowering snow levels. That's good for producing swell, but these systems tend to be pretty dry. Very minimal snow production is expected, but still some. Anyway, so there's one. You can just see it falling down into Tuesday, and then maybe another little pulse on Wednesday into Thursday, and now we're out into Friday. That fades off. The jet continues consolidated off Japan, but getting weaker. The split point remains on the dateline. Not a whole lot changes. Then here comes another pulse on Saturday. Will it make it towards California? Probably not. More for the Pacific Northwest or even British Columbia. Jet remains consolidated here as of Sunday, and we'll just take it out towards the end of the model. And there you go. Now, little bit better hope for precipitation pushing down California as we get into Sunday night, a week out, as the jet, the northern portion of the jet, sort of retrogrades west a little bit. That'll open up maybe hope for precipitation, but not a lot. So what's going on here? The big picture is the active phase of the MJO, Madden-Julian Oscillation, is over here in the West Pacific, reaching, filling the Kelvin wave generation area. We'll get into that in a minute. But what that typically does is support a consolidated jet stream flow. It actually pushes energy up into the atmosphere wherever the active phase of the MJO is. That in turn feeds the jet stream. The jet stream in turn feeds storm development. But then wherever the active phase isn't, like over in the eastern Pacific, the jet gets weaker, it splits, and you end up with this sort of a pattern. So let's take a look at the effects of the jet stream down lower in the atmosphere, down at the surface, because that's really what matters, right? Wind blowing on the ocean, that's what produces waves. So right now, low pressure here in the northwestern Pacific, and actually, let's go take a look back just a little bit. And here we are, Saturday, midday, let's say, roughly. The gale started developing off Japan. What was that? 40-knot winds, building 45, 50 knots over a tiny little core. 50 knots, almost 55 knots Saturday night, pushing to the dateline, and then that's where we are now. The gale lifting north. Remember, the jet's coming right up like that, pushing north, splitting over here, so that will push the storm track to the northeast as well. And also notice, here's our low pressure inland. You can see the red isobars there. High pressure, 1040 millibar high, bulletproof high pressure, well supported by the split jet stream flow wrapping around the north and south of it. But there's a bit of gradient here, producing north winds at 35 to almost 40 knots. We saw 26-foot seas right in that area. Now, we roll this out. You'll see that gradient starts falling south on Monday. The low that was in the West Pacific goes north up above the Aleutian Islands, totally shadowed relative to our area. And then another little mini low sort of develops behind, tracking off Japan, producing 35, maybe 40 knot winds into Monday night. And then it too lifts north. High pressure reigns supreme, north winds along the coast in California, and you can just sort of see it from there. Not a whole lot happening. You need at least, let's say, 30 to 35 knot winds to get any meaningful swell. Yeah, a little bit on Friday here in the Gulf of Alaska, mostly out of the Northern California swell window. Anything pushing, getting developed by the jet pushing off Japan quickly goes to the northeast. This one, yeah, barely has some 45 knot fetch on Sunday. That's a week out, hardly believable, and quickly moving up into the Bering Sea. But also notice now low pressure, not inland anymore, but off the Pacific Northwest coast comes Sunday night, 35 knot winds. Better odds for some minimal swell to develop, and even that fades pretty quick. So the outlook not looking particularly good. So let's take a look at the effect of those winds on the ocean surface, and we're going back to 18Z Saturday, about 10 a.m. Pacific Standard Time in the West Pacific off Japan. Remember, there's a little gale developing here, 20-foot seas developing, building to 32 feet, 33 feet, let's say, over a tiny area Saturday night, and then later Saturday night, pushing to 39 feet, again over a small area. This is mainly targeting Hawaii, but also the U.S. West Coast. The Great Circle paths into into Northern California go something about like that right there. So energy pushing that way, sideband energy towards Hawaii, and then here's where we are today. And then we roll it out from there. The system quickly fades by Sunday night, gone for the most part. What's that, 26-foot seas? But remember, there's a little tiny gale that formed behind that, producing another area of 28-foot seas, pushing somewhat towards Hawaii, and it too is going to face the same fate, pushing northeast. Brick wall split jet stream right on the dateline, no hope, and it's gone, and then things get rather dismal. You can see, though, systems falling, backdoor fronts, if you want to call them that, backdoor troughs, pushing down the U.S. West Coast, mainly good for wind swell. Just take a look. Now we get into Sunday. This is kind of new on the models. Up to 28-foot seas over a small area in the Northern California swell window. That's a week out. And falling southeast. Some swell could, very north-angled swell could result. Odds are there'll be wind associated whenever the swell does hit. But this is a week out. Don't believe the models that far into the future. Also looks like wind swell working its way into Hawaii at that time. Trades likely nuking given strong high pressure in this area right north of the islands. A quick look at local winds, mainly for California, but you can also follow Hawaii here. Trades blowing pretty good. Remember, there's your 1040 millibar high, and it's basically going to stay in this position for the entire week, maybe retrograde a little bit to the west. Low pressure inland. There's your fetch relative to California. We're getting into Monday morning, north winds, 30 knots, for most of Northern California, all the way down into Southern California. Not good. Trades holding east of the islands. Yeah, good for wind swell. More of the same. High pressure falling south into Tuesday. Little bit of a local low pressure. Again, remember the jet stream doing these backdoor trough kind of things. 10, 20 millibar low. That's not much of a low at all. A little break in the winds, maybe some south winds come Wednesday relative to California. Trades holding steady south of the high, east of Hawaii. Then another bout of north winds shaping up on Thursday, 30-knot north winds. Low pressure inland, not much, but just a little bit. Trades continuing, starting to work their way into the Hawaiian Islands as of Friday. North winds continue for the California coast as we get into Sunday. And then here comes our new low developing actually in the swell window, aimed pretty good. We get to 180 hours. Not sure when or if this system will even develop and if it produces swell, when that swell will hit. But as of right now, maybe there'll be a little break in the winds. Wouldn't believe it yet relative to California. Trades, 30 knots, just northeast of the Big Island, and 25 knots working their way into the northern shores of Oahu and Maui. And then a quick look at precipitation. Now remember, here we are, Sunday night, 4 p.m. Standard Time. Low pressure inland over the Great Basin. High pressure off the coast, 1040 millibars. Precip between the two, falling south. Snow supposedly starting to develop for Tahoe at this very moment. Falling south. This is light snow. Dusting, maybe a couple inches. We'll take a look at the forecast in a second. And then it dries out. Another little batch of precipitation, mainly pushing down the coast, not inland, until you get to Thursday. Then another little patch of snow and maybe some rain. And that fading out come Friday. And then yet here comes another system as we get into Saturday and Sunday, but it falters, fails to materialize in the forecast window. Just a quick look, Squaw Valley snow forecast. Looking out, you see a total of what, maybe 12 inches over a 10-day run of the model. You can pick it out. Supposedly a couple inches. What's that? This is accumulated total. So 5 inches, 5.7 inches into Monday. And then another little dribble come Thursday, maybe 2 inches or so. And then maybe a little bit more come Monday, maybe 3 inches, something like that. We've been working on some software trying to work out snow levels and freezing levels. Here, Lake Tahoe, just 3 hours, GFS model. This column here is the snow levels, and you can see as we get into Sunday night, snow levels falling down to, according to this, almost sea level, or 1,500 feet, something like that. Yeah, of course, that's well below lake levels. Lake level, Lake Tahoe, 6,400 feet. And the freezing level, 32-degree temperatures, just a little bit above that. You can just sort of work your way down. Relatively cold air. Remember, Arctic air mass is falling south the whole way through the week and continuing a week out into Monday and beyond. So bundle up. It looks like it's going to be cold in California for the next week. Let's take a look long term. What's going on? A week out, month out, multiple months out. All driven by the MJO and ENSO, the El Nino Southern Oscillation. First off, we like to look at what's going on with the MJO, the Madden-Julian Oscillation, a periodic weather oscillation. Actually, it goes from the active phase to the inactive phase, moving from west to east across the Pacific on the equator. Its biggest effect is in this area we call the Kelvin wave generation area. That's basically the western equatorial Pacific from 135 east. That's New Guinea right there. The date line is right there. This is the equator. This is the far east Pacific here. And the Kelvin wave generation goes to about 170 west. So 5 degrees north and south of the equator. Draw a box right there. That's our area of interest. This is absolute winds, wind speeds, 5-day average from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, La Nina. You can see east winds blowing good. That's normal this time of year. We're pretty much moving into spring now. But you see one little arrow there, an arrow there of westerly winds. That's not westerly anomalies. That's actual westerly winds at the surface. That's a sure sign of the active phase of the MJO. The inactive phase produces trades or easterly winds stronger than normal in the Kelvin wave generation area. the active phase produces the opposite effect. It either mutes trade winds or actually turns them westerly, like it's doing now. And we know that we are in a pretty strong version of the active phase of the MJO at this very moment. That's what's feeding the jet stream, and that's what's causing the jet stream to be consolidated in the West Pacific, and that's what's producing whatever gales we have. But also remember, this is oscillation on top of an oscillation on top of an oscillation. The first oscillation being the seasons, right? We're in winter, moving towards spring. The second oscillation is El Nino, La Nina, a, let's say, year on or 2 year on, 2 year off sort of thing. We're in La Nina right now. That sort of doesn't trump spring, but it trumps whatever the MJO might do, which is a 3 to 4 week oscillation on and off. So though we're in the active phase of the MJO, we're in a La Nina period that's sort of muting the MJO, and we're also moving from winter into spring. That's likely taking a notch out of it as well. Anyway, let's look at anomalies. Differences from normal for this time of year. Winds, we're just looking at the arrows. Pretty normal, maybe light easterly in a couple little pockets over the East Pacific, but clearly from the west, at least for the time being, in the West Pacific. Again, another indicator of the active phase, the MJO. Quick look at wind anomalies for the past 5 days. Okay, this is just the east-west component of the wind. Okay, we're trying to see easterly or westerly bias here. Well, the reds and yellows suggest westerly bias. Kelvin wave generation area, there's the dateline right there. Here's the equator right there. South America, New Guinea, Philippines right there. Kelvin wave generation area. Draw a box right around in here. See westerly anomalies on the 12th of February, 13th, and you can go down. You can see not a whole lot of change, clearly indicative of the active phase of the MJO. And then 850 millibar zonal wind anomalies. This is over time, this past couple of weeks here. Reds suggest westerly anomalies, blues easterly anomalies. Dateline is right there, right there. Kelvin wave generation area, basically between these two tick marks, so you can just go down and see how we had easterly anomalies, inactive phase of the MJO in January. Then boom, a very strong and the strongest pulse of the active phase of the MJO in quite a while occurred starting in early February. Peaked out, we'll say somewhere around February 8th or 10th, something like that. And then here's where we are today. Another little pulse of the active phase of the MJO, all one cohesive unit so far this month. But as we get to about February 23rd, 24th, it looks like it's going to be fading. We see blues in the Kelvin wave generation area, indicative of the inactive phase of the MJO. So whatever support we're getting from the jet stream, and if you're sitting here grumbling, going, God, it's not doing a whole lot, well, guess what? It's only going to get worse, according to this. Looking at models, outgoing long-wave radiation, this is the statistic model. Blues suggest less sunlight reflectivity, negative numbers there. Meaning more cloud cover, meaning low pressure, meaning the active phase of the MJO. MJO is again right in this, or the Kelvin wave generation area is right in this little box here. So we're in the active phase of the MJO. Going 15 days out, you can see it per the statistic model slowly moving out of the Kelvin wave generation area. And the inactive phase here, meaning the reds mean more sunlight reflectivity, high pressure, and of course more sunlight reflectivity off the ocean surface, meaning the inactive phase of the MJO coming in 15 days out. The GEFS model, dynamic model, suggests basically the same thing. Active phase fading about a week out, inactive phase in control, but not particularly strong. Next up, phase diagrams. One of these obviously not working, so we'll use the GEFS model one right here. So assume you're looking down on the North Pole. The active phase of the MJO moves from west-east, from the Indian Ocean over the maritime continent, like Bali, over the West Pacific, across the dateline, across the Pacific, under the U.S., on the equator, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now, and the further it is away from the circle, the stronger it is. So you see the active phase of the MJO was extremely strong the end of January into early February, but since February 8th, it's been getting weaker and weaker over the dateline. It's stalled right there, and it's supposed to basically hold that strength now, but move rapidly off to the east. And as we get into 15 days out, the active phase is to be all but non-existent in the Indian Ocean and gone. The presumption is the inactive phase, the MJO, will be in control at that time. And then the upper level models, again, South America here, Australia here, New Guinea here, Kelvin wave generation area. right about in this area. Green suggests areas favorable for precipitation. That is the active phase of the MJO. This runs about a week or two ahead of what's really going on the surface. This is up way above, at jet stream level or above. Anyway, you can see the greens progressing off the chart as we get into mid-March. That's the active phase of the MJO moving out of the Pacific. Inactive phase moving in. You can see here yellows, areas less favorable for precipitation. The inactive phase makes its way out of the Pacific Basin come about the end of March, and the active phase again returns. So if there were another window for swell production, one would say maybe late March or so, early April. But also note here, we'll see whether this happens, but typically what happens is the active phase, so wherever the active phase is, north of that is where precipitation is. So right now, most of the precipitation, let's say, is on the dateline area, and as it moves east, it will move under California. So the better window for precipitation from an MJO perspective is, let's say, late February into early March or so. We'll see whether that plays out. Then our favorite model is CFS 850 millibar winds. Again, these are east-west component of the wind, up about 4,000 feet, a good proxy for what's going on down at the surface. Dateline is right around here, Kelvin wave generation area between here and here. Just take our word for it. We can't show the scale very easily. Anyway, we'll overlay the MJO here. The heavy contours are the active phase of the MJO. The oranges and yellows are westerly wind anomalies. So you can see it right on the date line there today. And you can see the inactive phase already starting to build in the West Pacific. And about by February 26th or so, fully in control, inactive phase. And though it shows like two separate cells here, consider this all one pulse of the active phase of the inactive phase of the MJO. But the thing to notice here is a little bit of blues, a little bit of easterly wind anomalies, but also an equal number of yellow shading, meaning westerly anomalies, suggesting that perhaps the inactive phase of the MJO is losing some of its push. Now, here's the story. In La Nina, typically that favors the inactive phase of the MJO, and that's why during La Nina years you typically don't get a lot of surf, a lot of storms, a lot of precipitation, because the La Nina is feeding or biasing in favor of the inactive phase of the MJO, so they sort of work together. Likewise, during El Niños, they favor the active phase of the MJO, and that's why you get a lot more surf and a lot more storminess and weather, etc. Anyway, and we'll show you more in just a second on that. And then finally, as we get into, let's say April 7th or so, the active phase returns, moving from west to east across the Pacific. Westerly anomalies build, and presumably more or better odds for storm production. Now, low-pass filter. Here's where things get interesting. So this sort of shows you the solid contour is the area, we'll say, biased in favor of low pressure. And during La Nina, that area tends to be pushed over. You can't see it here on this chart. Maybe we can do this. There we go. In the Indian Ocean. And that's where it's been for coming on about a year and a half now. But notice the solid contour starts moving more and more off to the east and filling the Kelvin wave generation area by about mid-April or so. And then this dotted contour here is the area, the La Nina signature area biased in favor of high pressure. It's right in, you can see here, it's been dominating the Kelvin wave generation area, but as we get into, what's that, about the end of March, it's completely out of the Kelvin wave generation area. So, from purely this sort of perspective, we have better odds for storm production as we move into, let's say, the first week of April, because supposedly La Nina is to be dead, moving out of the Kelvin wave generation area. But the other oscillation you have to consider is the seasonal oscillation. We're into spring, the North Pacific starts shutting down. So there's no real expectation that a whole lot's going to be happening from this. But what this does suggest is that perhaps by next fall, we'll be in a much better position for storm production, swell production, and perhaps rain and snow production along the west coast of the United States. And just one more bit of data. This chart shows you the strength of the active phase of the MJO. It doesn't show you where it is, just the strength. We've seen this before. We saw as we got into January 2016, the MJO, the strength, started petering out a bit as La Nina started building its footprint. It faded for a little bit. There's a warm pocket of water that built off of Peru in the February timeframe, February, March, April timeframe of 2017. But then as we got into the summer last year, virtually no MJO activity. That explains why there was very little surf. MJO doesn't have as strong a correlation in the southern hemisphere as the northern hemisphere, but it does have a correlation just the same. And then notice just recently the MJO started maybe in November, a pulse, a little bit of dribbles in January. Now this most recent pulse, you see it's the strongest it's been in, going back to the big El Nino of 2015. Now this doesn't mean that El Nino is forming, but what it does suggest is that perhaps La Nina is fading. The active phase of the MJO is getting its opportunity to manifest itself a little bit. It's not being suppressed anymore. If anything, it's overcorrecting a little bit. But what that's also doing is helping to kill La Nina, and we'll explain that in a minute. So let's take a look at subsurface ocean temperatures. We're going down in the ocean. West Pacific here, East Pacific here, okay? And this is on the equator, 2 degrees north and south. You can see warm water, this is centigrade, 28, 29, 30-degree temperatures, all balled up in the far West Pacific, 28-degree isotherm, straight up and down, meaning there's sort of a headwind of cool water pushing on it here, so it can't start reaching off to the east. But the major improvement here, just in the past week or so, is the 24-degree isotherm, which was pretty much dying somewhere around 130. All of a sudden has built a little bit, reaching into Ecuador. So there's 24-degree temperatures Celsius at the surface now where there was none, suggesting that perhaps, remember, there's strong east winds blowing across here. These strong east winds are losing some of their grip, or that something else is going on. Either way, it suggests La Nina is weakening. Now we take a look at anomalies, differences from normal for this time of year. Interesting here, big ball of 3-degree temperatures above normal. They weren't there 2 weeks ago, but we do know we've been in the active phase of the MJO, a very strong one. West anomalies blowing for 2 or 3 weeks in this area. That helps produce what's known as a Kelvin wave. Warm water in the West Pacific starts building at subsurface, starts pushing down around 100 meters, 150 meters, the whole way across the Pacific, then erupts along the coast of Ecuador, Peru, forms a warm pool. And that's how, if this happens multiple times in a row, how El Nino gets started. Now, we're not saying El Nino is getting started, but what we are saying is, hey, the active phase of the MJO is working, starting to wake up. We just had a Kelvin wave a week and a half ago that made it the whole way across. That took a pretty good hit out of La Nina. We'll show you more about that. And it looks like perhaps another one might be forming. Now, a week ago, we had a thin little stream of neutral temperatures, the trailing end of that last Kelvin wave, going the whole way into the East Pacific. That's faded. We have 2 degrees below normal anomalies right now. That's because the inactive, but the thought is, well, some of the inactive phase helped feed La Nina again, but now here we go again. Another Kelvin wave. Maybe it'll knock some more out of La Nina. Another high-res version of the same sort of data suggests warm water, 1, 2, 3, 4, 1, 2, 3, 4. 3.5-degree anomalies building in the West Pacific. Little trailing remnants, that finger of the previous Kelvin wave, working its way into the East Pacific, but also cool anomalies, 1, 2 shades, let's say 1-degree anomalies, generalized here, but where previous we had 3 and 4-degree below normal temperatures, very solid in the East Pacific, they're all gone now. And it's just sort of this generalized, we'll call it a hangover from La Nina almost, in effect in the East Pacific. Upper ocean heat anomalies, that is differences from normal for this time of year. And we're going back a year, March last year, warm water in the West Pacific, a little bit of a Kelvin wave. Remember we talked about this April, May time frame of last year. Not enough to be called a La Nina, but sort of a mini La Nina. That helped fuel the extreme rain pattern of last year. Then another little Kelvin wave pushed through in the June time frame, warm water pushing to the east, and then La Nina set up in earnest last fall. Here's our La Nina, cooler than normal anomalies filling the entire eastern Pacific, but then just recently in January, we saw, late January, here's a little Kelvin wave, a little bit of warm water dribbling off to the east. Now here's where we are, the inactive phase, the MJO, sort of a cool response, a downwelling Kelvin wave. But now it looks like another upwelling, warm Kelvin wave trying to build in the West Pacific. We'll see if that really happens. If that does, that will help to put a damper on La Nina. Next up, sea level anomalies. That is differences from normal for this time of year in the height of the ocean. We're not talking waves. Strip those out. Strip wind waves out. Strip the tide out. Just the absolute level of the ocean surface compared to normal. What you're seeing is a little dip here. Again, we've been noticing this for quite a while. This is a sign of La Nina. It means cool water at depth. Cool water contracts, creates a little dip on the ocean surface. Warm water and a rise, 5 centimeters, 10 centimeters in the West Pacific means warm water at depth. Warm water, of course, expands, creates a little bump. So all this is doing is saying, yeah, what we saw in the other charts, it all seems to fit together and make sense. All right, let's take a look at sea surface temperatures. And here where there is a significant improvement to notice, okay? Right along the coast of Peru, Chile, Ecuador, Central America, warm water building up where cool water previously was in control. Now we have a good finger of warm water. Now this is just along the coast here. The main Nino monitoring region, the El Nino La Nina region, is 120 west out here, out to about 175 degrees north and south of the equator. But typically the way this works is you get warm water building here. The trades, of course, are blowing from the south, southeast, and then east in the southern hemisphere, northeast, and then east in the northern hemisphere. And this warm water at some point is going to start bleeding and filling into the main Nino monitoring region. And so this is an early sign of potentially the end of La Nina. This driven by the active phase of the MJO that's been in control now for several weeks. We think that's what's suppressing trades, causing warm water to build in this region. 7-day trend, sea surface temperatures. That's not a long time, 7 days. But we've seen this trend continuously now for weeks. Warming temperatures, the oranges, the yellows, the reds, suggest warming along Chile, Peru, the Galapagos especially, and now out to a point south of California. No signs of cooling. That's what, last little blue there, some little pockets way out south of Hawaii. But it appears that at least on a 7-day trend, water temperatures are warming. That is a good sign. And then on the backed off view, even more good news. You see your warming here along the coast of Peru, Chile, Peru, Central America. But then the real cold temperatures, these blues, were really lodged right around here, around just off the Galapagos weeks past. Now there, look at that, little pockets of warming starting there. And most of the cool temperatures are from 120 west. And these did extend the whole way solidly cooler out to about here. But notice they're even starting to erode here. All this suggests, well, we still have this big pool here kind of cooler water, but not horribly cool. All this suggests that La Nina is kind of getting severely eroded by multiple pulses of the active phase of the MJO. And if that continues, then that could mean the end of La Nina. Looking in the Nino 1.2 region, the area right along Chile, Peru, and the Galapagos, you can see sea surface temperatures, which spike. These are downward spikes, presumably of the inactive phase of the MJO. These upward spikes are supposedly the active phase of the MJO. You can see the effect is temperatures right now are only 0.3 of a degree below normal in the Nino 1.2 region. We know that to be true from all the other data, oranges and reds building up along the coast there. But this is not the official Nino monitoring region. This is just sort of the birthing area for potential warming in the Nino 3.4 region. Here's temps in the Nino 3.4 region. The official area, still almost a degree below normal, 0.916 degrees centigrade below normal. The expectation, though, is as warm water builds in the Nino 1.2 region, it'll advect or get sort of transported off to the west into the Nino 3.4 region. We should see temperatures starting to rise here. So what's the net effect on all this in the atmosphere? Well, we look at the Southern Oscillation Index. Difference in pressure between Tahiti and Darwin. Positive numbers suggest the inactive phase of the MJO over the short term and mean higher pressure over Tahiti. Negative numbers, like what we've had right here, look at that, minus 27, minus 22. It's just been going on and on. This suggests the active phase of the MJO. That means lower pressure over Tahiti, higher pressure over Darwin, and that's what we want to see. Clearly, the short term, the daily index right now, minus 13.11, very noisy. So we strip out some of that. We average it out all 30 days worth. You can see we were positive numbers suggesting the inactive phase of the MJO the end of January, but now numbers dipping, the index down to minus 3.65 today, suggesting it's a lagging indicator of the active phase of the MJO. And then the 90-day average, you can sort of use that to monitor El Nino, La Nina. We were hovering in the area of 5.5, which is weak La Nina. But now, look at the index. Nearly neutral at 0.31. Now, of course, the active phase of the MJO is in control. It's having an effect on this. As soon as it fades and the inactive phase builds in, this index will start rising again. Probably not that high, though, because the suspicion is we're going to have a weak inactive phase, followed by a stronger active phase if La Nina is, in fact, dying, and this index should maybe start really readily hovering around 0. Here's the 30-day moving SOI average charted out back in 2016. We were in, of course, El Nino, negative numbers. That's what the SOI. And you can actually see the pulses of the active phase, inactive phase, active, inactive, etc. Then we moved into July 2016, and we started working our way towards La Nina. 2017, a little bit stronger, but you see this La Nina is not very strong, never got very high. There's our inactive phase of the MJO, an active phase. Here's the inactive phase that we're currently in. We expect this to come up a little bit. But if you're going to draw a line through this whole thing here, put it maybe right about there. 5, that's not much of a inactive phase of the MJO, where our El Nino was down around minus 15 or maybe minus 17 as an average. So, again, pretty weak La Nina. We'd like to show you the ESPI index also, but it's dead. Something's going on with the site. It hasn't changed in a couple of weeks. NOAA, we assume, is working on it. We'll reach out to them if they don't fix it shortly. So to wrap things up, a couple of pulses, literally 2 small pulses of swell for Hawaii. Some of that energy will make it to the U.S. West Coast at the most exposed breaks, but the bigger issue is going to be larger, more dominant local north wind swell. So probably not great surf conditions relative to California. At least a little precipitation is in the mix, but cold temperatures. So this is a La Nina. It is very typical during La Nina to have an early spring and to have nuking north winds. And we suspect that's what we're going to have to suffer through from now till, probably later April, something like that, maybe May. And then finally, when La Nina is dead, the high pressure will break down a little bit and wind will back off some. Hopefully, the southern hemisphere will be a little bit more active because if we're moving out of La Nina, then the active phase of the MJO, of course, is a little bit more dominant. That might feed the storm track in the southern hemi, and maybe we'll get an early start, but that's a wild guess at best. For now, we're going to assume not so great conditions for the next couple of months, but if we pay that price, we think the worst of it is going to be over. Anyway, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.